Hello there, Mr. Sutton here, bringing you the Algebra 2 5-7 homework solutions, or if you're doing the honors, this is 5-7 Part 1 homework solutions. All of this on finding inverses of functions. For this problem, we're going to find the inverse of this function and then graph it along with its inverse using Desmos. So we'll start by switching the x and the y values. So we can rewrite this as x equals negative 2y plus 5. And then we'll just isolate y. So first step to doing that, we have to subtract 5 from both sides, so x minus 5. And then we'll divide both sides by negative 2. So I can write f inverse, or y, equals x minus 5 over negative 2. All right, let's go to Desmos and see what this looks like. So let me do my original function. F of x equals negative 2x plus 5. It's a line. And then let me do the inverse function, which I'll write as g of x. And that's, let's see here, fraction x minus 5 over negative 2. And then let me just graph the line y equals x. And that shows that we do have indeed a reflection over the line y equals x. So there we have it. For this one, we're trying to find the inverse of this quadratic function, which has a limited domain so that we can actually find the inverse. So let's switch x and y. We have x equals 9y squared. And now let's solve for y. First step to doing that is I'm going to have to divide both sides by 9. So we have x over 9. And now I have to square root both sides to get y by itself. Now normally this would give me a plus or minus square root because I'm square rooting an equation. However, since they told us that x is less than or equal to 0, since we have a domain that's negative numbers, that means the range of the inverse has to be negative numbers as well, because we're basically swapping domain and range. So this is going to have to be a negative radical x over 9, which if I want to, I could simplify to negative radical x over just plain old 3. All right, let's graph these on Desmos. So we have the original function, f of x equals 9x squared. And to get that restriction on the domain, I'll use curly brackets and do x less than equals. And now let's do 0. And that gives me just half of that parabola. And now if I go ahead and graph my inverse, which I'll call g, so negative, let's see here, fraction, sqrt for square root, put an x up there, put a 3 down there, and let's just graph y equals x just to make sure we have a true reflection over that y equals x line, and it looks like we do. To get the inverse of this quadratic function, it's going to take a few steps here, and notice that we have this limited domain so that we can get an inverse. So let's start by switching x and y. I'll write this as x equals negative y minus 1 quantities squared plus 6. And now we start the process of isolating y. First step, I'm going to have to get rid of this plus 6 by subtracting it to the other side. Next, I need to get rid of this negative so that I can get the squared stuff by itself. So I'm going to rewrite this stuff over here as negative parentheses x minus 6. If I wanted to, I could have written this as 6 minus x. Either of those are equivalent. And now I'm going to have to square root both sides. So to do that, I have a plus or minus normally. Since I have a domain that's giving me all the x values to the right of the vertex here, that means I'm going to want positive square root. So we'll do positive radical of that stuff equals y minus 1. And then one final step, just add 1 to the other side. So we have f inverse equals all this square root stuff plus 1. And again, the stuff inside the square root, you could call this 6 minus x if you wanted to. So let's graph this on Desmos. Let's start with the original function, f of x equals negative parentheses x minus 1 squared plus 6, curly bracket, x greater than or equal to 1. So that's what that half a parabola is looking like. And then let me do my inverse, g of x equals, let's see here, sqrt, square root, negative parentheses, x minus 6, close that, get out of the square root, plus 1. And Let's just graph y equals x. And it looks like we do have a reflection, so we have correctly found the inverse. And there's the graph to prove it. To find the inverse of this cubic function, let's start by switching x and y. So we have x equals negative y cubed plus 2. And now let's isolate y. So first step to doing that, we'll subtract 2 to the other side, so x minus 2. And then I have to divide both sides by this negative 1 here. Now when I do that, I have a negative x and a plus 2, which I could write as a 2 minus x if I so desired. Next, to get y truly alone, I have to cube root both sides. So I have f inverse of x equals cube root of 2 minus x. And now let's go to Desmos and graph all this. So I have the original function of f of x equals negative x to the third plus 2. There's the original. And now g of x, my inverse, that's going to be cube root CBRT. And then we have 2 minus x in there. And then let me just do y equals x just to see if I have that line of reflection that's working. Yep, it looks like these are reflections of each other. So that means this is the inverse. For this next problem, we're going to be finding the inverse of this radical function. Let's start by switching x and y. So we have x equals square root of y plus 4. Next, I need to isolate y. So one step to doing that would be to square both sides to get rid of this square root. So we'll have y plus 4 equaling x squared. And then just subtract 4 to get f inverse equals x squared minus 4. Now, before I go ahead and call it a day on this one, because my original function here has a limited range, since this is square root, I can't return negative values. I have non-negative values. That means that since the range here is limited, that means the domain of my inverse is going to be similarly restricted. So for my domain for this, I need to have positive or at least non-negative x values. So I need to do x greater than or equal to 0. And I really have to spell this out because it's not kind of implied and built in normally to this quadratic, but this is a limited domain that we're working with for this inverse. All right, let's go ahead and graph these on Desmos. So we have f of x equals sqrt of x plus 4. That's the original. And now I'll do g of x for my inverse, and that is x squared minus 4. Which normally looks like this, but again, I need this domain restriction in there to reflect the range restriction of my original. So let me do curly braces, x greater than or equal to 0. And now once I've done that, and I graph that line y equals x in there, we see that we have a true reflection. So this is actually the true inverse with this restriction. On this one, we are going to be finding the inverse of a cube root function. Let's start by switching x and y. So we have x equals 2 times cube root of y minus 5. Next, let's isolate y. So one step to doing that is dividing both sides by this 2. So we have x over 2. And then to get to y, I also need to get rid of this cube root by cubing both sides. So we'll have x over 2 cubed over there equals y minus 5. And then finally, I can just add 5 to both sides. And while I'm at it, I'll simplify this cube. So x cubed over, let's see, 2 cubed is 8, and then a plus 5 there to go with that. And all of that is my f inverse. Let's go to Desmos and make sure this is the true inverse. So first, let me graph my original. F of x equals 2, and then CBRT, cube root of x minus 5. That's what the original looks like. Now for g of x, my inverse, we've got, let's see here, fraction x cubed over 8 plus 5. And let me just graph y equals x to make sure that lines up perfectly. Yep, those definitely look like they are reflected over this line. So this is then the true inverse.